First question, what is the definition of differentiation? Differentiation is a fundamental concept in calculus dealing with the rate at which a quantity changes. It is the process of finding the derivative of a function, which provides information about the slope of the function at any given point. Next, techniques of differentiation. First, power rule, used to differentiate powers of x. Next, constant rule. The derivative of a constant is 0. Next, quotient rule, applied when one function is divided by another. Next, chain rule, used when a function is inside another function. Next, product rule, applied when two functions are multiplied. Next, trigonometric rule, for differentiating sine, cosine, tangent, and other trigonometric functions. Next, exponential rule, for differentiating exponential functions. Next, generalized power rule, an extension of the power rule when the base is a function. Last but not least, logarithm rule, for differentiating logarithmic functions.
Next, I will proceed with the question 2a. For the question 2a, we need to find the dy over dx for y equals to square root x cosecant 2 minus 3x. First of all, we can see that this function has two functions multiplied together. Because two functions is multiplied, we can use the product rule. The first step is identify u, v, u prime, and v prime. Let u equals to square root x and let v equals to cosecant 2 minus 3x. Next step is differentiate u and v. For u equals to square root x, we will write the square root as the power form. So, u prime equals to x to the power of 1 over 2. U prime equals to 1 over 2x to the power of 1 over 2 minus 1. U prime equals to 1 over 2x to the power of negative 1 over 2. And the final is u prime equals to 1 over 2 square root x. Next, v prime equals to negative cosecant 2 minus 3x got 2 minus 3x multiplied by negative 3. Negative times negative become positive. So, v prime equals to 3 cosecant 2 minus 3x got 2 minus 3x. The step 3 is substitute into the product rule formula. First, we write the product rule formula. dy over dx equals to uv prime plus vu prime. Substitute all values into the formula. dy over dx equals to square root x multiplied by 3 cosecant 2 minus 3x got 2 minus 3x plus cosecant 2 minus 3x multiplied by 1 over 2 square root x. The step 4 is simplify. First, we simplify the first term equals to 3 square root x cosecant 2 minus 3x got 2 minus 3x. Next, simplify the second term equals to cosecant 2 minus 3x over 2 square root x. Step 5. Final answer. dy over dx equals to uv prime plus vu prime. dy over dx equals to square root x multiplied by 3 cosecant 2 minus 3x got 2 minus 3x plus cosecant 2 minus 3x multiplied by 1 over 2 square root x. The final answer is dy over dx equals to 3 square root x cosecant 2 minus 3x got 2 minus 3x plus cosecant 2 minus 3x over 2 square root x.
Alright, next let's take a look at this example. Differentiate the following function using the quotient rule. So first of all, when we got the question, we need to identify the value of u and also the v. So what is actually u, what is actually v? U is actually the numerator and also v is the denominator. So from that, in this question, we know that the value of u is equals to 2x squared plus 1 to the power of 3, and the value of v is equals to third x squared plus 4. So from this information, we can find the u prime and v prime. So from that, we need to differentiate the function. So the function given 2x squared plus 1 to the power of 3, we need to apply the chain rule concept to get the answer. So u prime is equal to 2x in bracket 2x squared plus 1 to the power of 2, and v prime is equals to x over third x squared plus 4. Alright, so we already have all of the information such as u prime, v, and also v prime. So from that, we can substitute everything in the quotient rule formula. And also, the next step is simplify them. Alright, after simplifying, you need to make sure the denominators is the same so that you can get the best final answer. So from that, you need to expand everything. Hence, the final answer for this question is 3y dx equals to x in bracket 2x squared plus 1 to the power of 2 in bracket 10x squared plus 47 over in bracket x squared plus 4 to the power of 3 over 2.
Okay, so let's move on to question 3, which is given 3y squared ln x power of 3 plus 2x power of 5 equals to 210 x squared minus 1 minus e power of y squared. Find dy over dx using implicit differentiation. So step 1, find the product. The product is 3y squared ln x power of 3. U equals to 3y squared, v equals to 1x power of 3. Differentiate u and v with dy over dx. U primes equal to 6y power of 2 minus 1 dy over dx. It becomes 6y dy over dx. V prime equal to 1 over x power of 3 multiply 3x power of 3 minus 1 equals to 1 over x power of 3 multiply 3x squared equals to 3 over x. Step 2, substitute all into the product rule formula. dy over dx equals to 3y squared multiply 3 over x plus ln x power of 3 multiply 6y dy over dx equals to 9y squared over x plus ln x power of 3 6y dy over dx. Step 3. We need to differentiate left side of the equation 3y squared ln x power of 3 plus 2x power of 5. From step 2, substitute into this equation and differentiate 2x power of 5. 9y squared over x plus ln x power of 3 6y dy over dx plus 10x power of 5 minus 1 equals to 9y squared over x plus ln x power of 3 6y dy over dx plus 10x power of 4. Step 4, we need to differentiate right side of the equation equal to 2 second square x squared minus 1 multiply 2x power of 2 minus 1 minus 2y e power of y squared dy over dx equal to 4x second squared x squared minus 1 minus 2y e power of y squared dy over dx. Step 5, so the equation becomes 9y squared over x plus ln x power of 3 6y dy over dx plus 10x power of 4 equals to 4x second squared x squared minus 1 minus 2y e power of y squared dy over dx. Then we need to allocate them the terms with dy over dx on one side of the equation. Ln x power of 3 6y dy over dx plus 2y e power of y squared dy over dx equals to 4x second squared x squared minus 1 minus 9y squared over x minus 10x power of 4. Then we need to factor out dy over dx. It becomes ln x power of 3 6y plus 2y e power of y squared dy over dx equals to 4x second squared x squared minus 1 minus 9y squared over x minus 10x power of 4. So the final answer is dy over dx equals to 4x second squared x squared minus 1 minus 9y squared over x minus 10x over power of 4 over ln x power of 3 6y plus 2y e power of y squared.
We discuss one of the question that I choose. Use linear approximation to estimate the value of any correct to 3 decimal place. Fifth root 32.25 minus 1 over fifth root 32.25. Okay, first we have to identify the value of fx. Fx equals to x power of 1 over 5 minus x power of negative over 5. Okay, second we have to choose suitable value of a. I choose a equals to 33 because if we change 32.25 to 32, we got the answer is positive. Fifth step, we have to find f32. That means we have to substitute x equals to 32. f32 equals to 32 power of 1 over 5 minus 32 power of negative 1 over 5 equals to 2 minus 1 over 2 equals 3 over 2. Step 4, we have to find the derivative f prime x. F prime x equals to 1 over 5 x power of negative 4 over 5 plus 1 over 5x power of negative 6 over 5. Fifth step, we have to find f prime 32. That means we have to substitute again x equals to 32. F prime 32 equals to 1 over 5, 32 power of negative 4 over 5 plus 1 over 5 multiple 32 power of negative 6 over 5 equals to 1 over 80 plus 1 over 320 equals to 1 over 64. We have to apply the linear approximation formula. We have to apply x equals to 32.25. Fa is 32, f prime a is 32, and x is the 32.25 minus a is 32, right? And it will be 0.25. Okay, it will approximately 3 over 2 plus 1 over 64 and multiply by 0.25, and it's equals to 1.504. That's all from me. Thank you.
In conclusion, the techniques of differentiation in calculus provide systematic ways to find derivatives of many types of functions. By applying rules, the problem becomes easier to solve and understand.